Good afternoon, everyone. Please come on in. If you're waiting outside, this is the place to be. I don't know if they're still banging the crockery to get people in. Good. Thank you, and welcome to the session on sustainable hydropower and green hydrogen. Congratulations, you're in the right place. This is a discussion that we need to have here because, we've all been listening over the last day and a half, and we've heard, quite rightly, a lot about wind and about solar being the sport. But we mustn't forget what Fatih Birol calls the forgotten giant of the renewables, hydropower. And I think Paolo Frankel also repeated that on stage yesterday, that expression, the forgotten giant. And I think that's a challenge here. We're going to have, over the next decade, a huge amount of wind come onto the system, a huge amount of solar, and that's very welcome. But we also need to make sure that that is balanced. What is it we're going to do to make sure that we have a balanced portfolio going in of firm energy? Because when the wind doesn't blow and the sun doesn't shine, we need to have that backup all the way through. So that is the way that wind, solar, and hydro together work and complement each other. Plus, there's a big advantage, a big important message. Hydropower is very plentiful in many of the countries that we're focusing on, many of the developing countries and emerging economies. So this is where a lot of their capacity and potential will come from. It is an excellent source for green hydrogen. That's what we're going to be exploring. I would say, given that hydropower at the moment is just given up its title as being bigger than wind and solar put together in terms of installed capacity. So now they're more or less at the same level. But given all of that, the idea of getting to 100 million tons of green hydrogen by 2030 without a large proportion of sustainable hydropower, it's a fantasy. We will need to look at how to not only use existing installed capacity, but to grow it. And that's what we're going to be looking at. Lots of opportunities around the world, and also lots of challenges. My name is Eddie Rich. I am the CEO of the International Hydropower Association, which is an industry body promoting sustainable hydropower. And we represent companies and organizations all around the world. And we have worked right from the founding of the Green Hydrogen Organization with them. And of course, we share in Malcolm, our board member, but also the chair of the Green Hydrogen Organisation. And we're two sister organisations working very closely together. So that means that when you are doing your social media for this event, and I hope you will be, do please use the two hashtags, the GH2 Assembly and with hydropower. Right. Before I'm going to invite our very illustrious and capable panel onto the stage, I'm first of all going to ask for the video from the Director General of IRENA, Francesco Lacamera, who can't be here today. He sends his apologies. He was here yesterday. He's recorded us a little message. So with that, hit it.
Excellencies, distinguished guests, ladies and gentlemen. It is with great pleasure that I join this session today to speak on sustainable hydropower and green hydrogen from IRENA's perspective. I'd also like to take the opportunity to thank the Green Hydrogen Organization and the International Hydropower Association for organizing this important conversation today. As you know, ARENA promotes all types of renewable energy, naturally including hydropower. Recent events have caused an increased urgency to develop renewable energy for energy security as well as meeting our climate targets. Hydropower is a key part of this dialogue. Global hydropower capacity, including pumped storage hydropower, reached more than 1.3 terawatts in 2021. The ARENA World Energy Transition Outlook 2022 suggests that if the world is to completely decarbonize and meet the climate goal set in the Paris Agreement, hydropower installed capacity should more than double by 2050. Part of this demand comes from the need for renewable electricity for electrolysis to produce green hydrogen. This is an important link between hydropower and hydrogen. Nevertheless, any new hydropower developments will need to comply with environmental, social, and sustainability standards. But strategies and goals need concerted action to become a reality. One example is financing. Historically, hydropower has been a source of base load generation. However, with higher share of variable renewable electricity, it is used more frequently for peak loads and as a source of ancillary services, a fact that can limit power generation volumes and reduce revenues. It is crucial that we look at ways to keep the hydropower business profitable. One possible solution is to allow power purchase agreements between hydropower and hydrogen producers. Using hydropower to make hydrogen allows extended use of the plant and helps to avoid underutilized hydropower assets. The potential is even larger when considering pumped storage hydro, which can also store surplus electricity and off-peak electricity for use to produce green hydrogen. We can only achieve the energy transition together, in collaboration between countries and leaders. ARENA will continue to work with the IHA to bring our members together to progress our joint mission under our partnership. We call upon governments to develop policies that enable the scale-up of green hydrogen and the decarbonization of power grids, whilst recognize the important role that hydropower plays. I wish you a good session. Thank you very much for your attention.
Excellent. With that, is this on? Yes. With that, let me invite the panel up to the stage. Malcolm Turnbull, who I think you all know, please come up. Sharon Becker, I'll do the introductions properly later on. I'm just calling out the names. Marcelo Costa, Jérôme Pacres, and Antoine Vanya-Jones. Thank you very much. Welcome. Yes, you can give them a round of applause. Why not? They haven't done anything yet, but they will. They'll work for that. Good. I'm going to start with Antoine. So Antoine, you're from Bloomberg. Yes, grab yourself a microphone. And Antoine, you're the head of trade and supply chains at Bloomberg. You're an analyst on this. I think most of us saw the presentation that your colleague Kobad did yesterday. And he set out, I think, very clearly the very impressive and exciting growth forecasts for green hydrogen. Get to, what was it, 800 million tonnes by 2050. Can you paint a picture of how that's going to play out, particularly in terms of how much of that might be from hydropower?
Absolutely. Hi, everyone. For those of you who aren't familiar with Bloomberg NEF, we are a research provider focused on the energy transition, whether it's from hydrogen to demand sectors like heavy industry to the electricity that's required to produce that hydrogen, focusing on renewables. But we do look at the world's energy system, and that's what feeds into many of the projections that you just mentioned. So we produce a new energy outlook every year, and as part of that, we run a number of scenarios. And one of the scenarios that was shown yesterday by my colleague Kobad sitting here was a world where a lot of the power that's used to decarbonize the hardest to abate sectors is made using renewables and then green hydrogen in particular. So that ends up being about 1,200 megatons by 2050, and that's broken down across a number of sectors. But in the shorter term, that growth is going to be quite different according to different regions. So what we've done is sort of look at the fact that last year we saw a doubling of electrolyzer capacity to just under 500 megawatts, and we expect it to again grow extremely rapidly this year by a factor of 4 or 5. And that's going to be, the bulk of that's going to be in China, where there is a large hydropower fleet, the world's largest in fact. And then we're going to see large growth in the United States and Europe. Now in terms of end sectors, it's interesting to consider from the perspective of hydropower that there are certain industrial clusters that are co-located with hydropower. So for example, we're seeing a few projects in Europe, H2 Green Steel, for example, Norsk Hydro, steel, aluminium projects to be created at very low cost using existing hydropower assets. And something that might be worth mentioning too is that when we look at countries across the board, the distribution of hydropower might be very disparate. But what we have is total installed capacity of around 1,000 gigawatts, a bit more than that if you include small hydro. And that's focused really in countries like China, like the United States, like European countries, all of which are sort of looking to increase their hydrogen consumption. So there's some synergies there. We do see the bulk of green hydrogen coming from wind and solar, but there's an existing fleet that needs to be used. And then in terms of how that will play out geographically, it will depend on availability of subsidies. So we track what's been announced by governments, what pots are available for developers. And there's around $100 billion of funding available today for hydrogen consumption or production. And that's, again, concentrated in those geographies, in the United States, in EU member states, at an EU level in pots like the Innovation Fund, for example. And that means that there is an alignment there as well, just in terms of what funding's available. So there are synergies there. We do see wind and solar's growth, the collapsing of cost there is driving a lot of deployment in hydrogen, but there's an existing asset base. I think an interesting question to consider, and maybe we'll talk about, is that of standards. So talking about how to certify, how to define renewable hydrogen, where hydropower fits within that, within the additionality criteria we're seeing talked about within the EU, which you may see clarity on today. But maybe we'll leave that for later in the panel. But that's the overall picture, where there's potential for growth, existing assets that could be utilized, and it may be worth thinking about where pipelines and construction can be optimized to align with demand centers going forward.
Great. And from the hydropower sector, I have to say, we're ready to play the part that we can in all of that. But there is a myth out there that there aren't hydropower sites, that we've reached capacity. That really isn't true. In looking in places like Africa, they've only tapped about 10% of their overall potential. But particularly when you look at pump storage, which we'll be coming on to later, off-river, there's a huge amount of potential in all of the regions. So let's get rid of that myth straight away that there aren't sites, that this is an industry that has hit its maximum. Let me turn next to Malcolm Turnbull. I think he doesn't need any introduction, but I will say a few things which are relevant to this, because you were a journalist, you were a lawyer, you were a banker until you went on to do lesser things by becoming Prime Minister. But you've had this incredible career across a number of fields, which really is important and helps to see this from different perspectives, to actually have an appreciation of the technical and the political and the communication and the legal aspects of trying to expand a sector from nothing. You're now, I'm delighted to say, a board member of the International Hydropower Association, obviously also chair of the Green Hydrogen Organisation. You have talked a lot about long-duration energy storage. I say sometimes that you put the rage in energy storage, but it doesn't quite work very well. But you've also called it the ignored crisis within the crisis. And can you explain a little bit more what you mean by this?
Yeah, thank you very much, Eddie. Well, you know, the reality is that we are moving from a world in which most of our electricity came from centralised thermal generation from burning coal, mostly coal or gas, but continuous generation, to particularly of coal, to one where most of our primary generation is going to come from intermittent sources, principally wind and solar. Hydro, of course, in some places is continuous. It's a baseload source of electricity, as the director of IRENA was saying earlier, but it is also dispatchable. It can be turned on and off, in other words, and that's a huge asset. So really, if we want to have 24/7 power, and of course we do, we want to keep the lights on, although we have demand fluctuates, and particularly if we want to make green hydrogen, and we want to have our electrolyzers running 24 hours a day. I mean, you know, let's not kid ourselves. If you have an electrolyzer that is only running when the wind is blowing or the sun is shining, it may not even be running half the day. It may be running a third of the day. Depends on where it is and what the weather is. So, you know, the capacity utilisation factor is hugely important in any industry. And so how are we going to maintain continuity of supply in this world where we have diminishing amounts of continuous generation? Obviously, countries with a lot of nuclear are in a different situation. The answer has got to be storage. The answer has got to, and you know, batteries have got an important role, but they are hugely expensive, frankly, and for shorter time periods. Long duration energy storage, really you're talking about hydro. Now that can be just conventional hydro in the sense that you don't open the gate valve on your dam, you keep the water in the dam when the sun is shining and the wind is blowing, and then you let it out when it's not. But if you want to have a really resilient hydro system, you need to have pump storage. And you can have very elaborate schemes, like the one I started in Australia, Snowy Hydro 2.0, which, you know, is a huge scheme. But the simple cookie cutter pumped hydro schemes, which are not expensive, are simply putting a turkey's nest dam on top of the hill next to an existing reservoir. I mean, we were talking earlier, Alan Krauss and I were talking earlier about Cruachan, and Eddie and I visited it recently. Classic case, it was done in the 60s, it's a dam in a gully, you know, it's like marginal sheep country, it's not, there's no environmental, that's what we'd call it in Australia, heaven knows what it is in Scotland, marginal Scottish, cattle country or something, but it's not the best country in the world. You've got a dam up there on top of the hill, you know, big pipe down to the lock, and water goes up, gets pumped up when electricity is cheap when the wind is blowing. In fact, sometimes they get paid to pump it uphill because it's cheaper than paying the wind farms to curtail. And then they run it down when it's expensive. That's actually the solution. Now, I am passionate about this. I think we run the real risk that we will put our continuous generators out of business and we won't have the backup to keep continuity of supply in a variable renewable world. So, this requires a bit of planning and foresight. And you've got to remember, it doesn't take you very long to build a solar farm or indeed a wind farm, but any pump storage scheme, even if it is straightforward, closed loop, involves civil works, and Moore's law does not apply to digging holes, as we know. But you've also got the issue of permitting. And this is really the single biggest thing that's got to be addressed. There's got to be, governments and planners need to identify what is an innocuous closed loop pump storage system and have a fast track way of approving them. Finally, and Francesco made this point earlier, you've got to have a financing model. Now, I commend to you what's being done in New South Wales. It's a system that's been designed by AEMO Services. AEMO is the Australian Energy Market Operator, which is responsible for basically all the electricity grid in Australia other than Western Australia and Northern Territory. So it's one of the biggest grids in the world. Very, very professional operation. And they've designed a model where they will provide where the state would provide an underwriting of revenues. So it's not per megawatt hour, because remember what you're seeking to do is get storage capacity. You want to be in a position, you want in effect some people to have water in the top reservoir to cover the system for when the wind isn't blowing and the sun isn't shining. And so they've got a system, a scheme there to do that. It'll be competitive, and so they will get the amount of storage they need for the duration they need at the lowest cost to consumers. So I think it's very admirable, and I've talked about it in Washington recently and at a conference there, and there's a lot of interest from the World Bank, Department of Energy in the US. I think they've actually come up with a pretty sweet idea. So there it is, Eddie. I think, and on site, just on sites, can I just make this point? Again, Australia, a guy called Andrew Blakers, professor at the Australian National University, has done a global atlas of pump storage locations, which are all off-river, all closed loop, none in national parks or environmentally sensitive areas. There are hundreds of thousands of places where you can do this. You don't need a lot of water. I mean, you basically need 2 big farm dams. That's what you're talking about. 5-6 billion litres is more than enough to provide you with hundreds of megawatts for many hours, for 8 hours plus. So it obviously depends on the elevation. But bottom line is we can do it. We can do it cheaply. We can do it in a cookie-cutter way, but we have to do it if we want to keep the lights on in a clean energy world.
Yeah, and that Andrew Blakers study identified 600,000 sites which are topologically fine, outside, all off-river, all outside protected areas, 600,000 sites around the world where it's topologically viable to do this. Now, if only 1 in 1,000 of those is possible, that still leaves you with a lot. So, thank you, Malcolm. We'll come back a little bit to some of those bankability points you made and around schemes like in New South Wales. But that ignored crisis within the crisis, if you only remember one thing today, the danger, if we don't plan for long-duration energy storage, we are going to stall in the energy transition just at the point when we should be accelerating. Let me turn next to Marcelo Costa, who is the chairman of IMSA, which is the Argentinian state-owned technology company in the renewables. Marcelo, there's big announcement with Fortescue, and they've investing over $8 billion in green hydrogen investment in Argentina. Can you give us a picture of what that's going to do and what the hydropower role within that is?
Thank you. Thank you, IHA and GH2 for the invitation. Thank you very much. If you don't mind, I'm in Spain, I'm a Spanish speaker. I would like to go on in Spanish, if you don't mind. Muchas gracias de nuevo. Efectivamente, hace aproximadamente un año, Fortescue nos contactó con un proyecto realmente muy significativo, muy impactante en Argentina, un proyecto escalado en el tiempo. Realmente no le vemos el final a toda la cantidad de generación eléctrica y electrólisis que se puede hacer, y la verdad que para nosotros es un enorme orgullo. IMSA es una empresa que tiene 114 años, fue capitalizada por el Estado argentino hace poco tiempo, es una empresa cuyo core business central es la producción de tecnología para generación eléctrica. Somos de las pocas empresas en el mundo que hacen turbinas para generación. Hemos hecho proyectos en los últimos 50 años en 42 países. Tenemos instalados aproximadamente unos 56 gigawatts de potencia en todo el mundo. La verdad que para nosotros el proyecto que nos presentó Fortescue es muy significativo. El proyecto Fortescue en Río Negro, en el norte de la Patagonia, es interesante porque son, digamos, se da la condición, la triple condición óptima de producción eólica que tiene la Patagonia Argentina, un lugar enclavado en vientos permanentes, en lo que los marineros del fines del siglo XIX en sus clippers denominaban los Roaring Forties, la longitud de los 40 de latitud de vientos rugientes, y en ese lugar está enclavado este pedazo de tierra de la Patagonia, con lo cual las condiciones de viento ahí son excelentes. Y tenemos agua en cantidad para la electrólisis, y el proyecto es un proyecto que va escalado, como decía, pero para 2030 nos indicaron que la potencia eólica va a estar en el orden de 4 gigawatts de generación. Han contratado con IMSA, que también tiene una división en el sector eólico. Han contratado ya todo lo que es la prospección de vientos, que en esa región no estaba hecho porque no había ningún proyecto anteriormente eólico tradicional, con lo cual en este momento se está realizando los trabajos de prospección de vientos. Y por supuesto para nosotros es un enorme orgullo. Nosotros, por supuesto, creemos que, coincido totalmente con Malcolm, hay que trabajar seriamente en la sostenibilidad y en la energía de base que va a necesitar este enorme proyecto en Argentina. Y entonces, además de colaborar en lo que es el actual proyecto de Fortescue, estamos trabajando y pensando a futuro en un proyecto de hibridación, de sinergia entre lo eólico y lo hidroeléctrico. Tenemos muy cerca de allí un encadenado. Quizá le pido a los chicos del sector que me pongan la foto. Bueno, ahí tenemos Sudamérica, lo que sería Patagonia Norte. La provincia de Río Negro es la que aparece en la foto. Y les pido entonces que pasemos. Bien, no quiero ser muy técnico, pero básicamente eso que se identifica en el sector delimitado en rojo, meseta de Somuncura, es una meseta donde se están haciendo los estudios eólicos. 625.000 hectáreas con potencial para muchos megas de producción eólica. Imagínenlo como una enorme cancha de fútbol a 1.000 metros de altura, con vientos permanentes de 9 a 10 metros por segundo, a 150 kilómetros de la costa de mar. El rectángulo en amarillo al sureste es el lugar donde estaría establecida la central de electrólisis, por supuesto, inmediata a un mar argentino con posibilidades para un puerto de aguas profundas para la exportación del producto. Pero no me quiero detener ahí, quiero que lleven la mirada hacia el noroeste, donde hay otra gran meseta Rentería. Es una meseta también, similares condiciones, excelente calidad de viento, potencial para entre 800 y 900 megawatts de potencia eólica. Esa meseta está a 30 kilómetros de lo que ustedes ven a la izquierda, que es lo que conocemos como río Limay. Ese río tiene un caudal de 750 metros cúbicos por segundo y actualmente, la foto de hoy, son 4 centrales hidroeléctricas, Alicurá, Piedra del Águila, El Chocón y Arroyito, que en suma generan aproximadamente unos 3.500, 4.000 megawatts de potencia hidroeléctrica. Esas centrales hidroeléctricas fueron construidas entre los años 70 y 90, 20 años de construcción de centrales, y están produciendo normalmente. Algunas de ellas son para potencia de pico, algunas de ellas son para potencia de base. Por supuesto que estamos pensando seriamente en vincular meseta de Rentería con producción eólica, con el completamiento, la completación del proyecto hidroeléctrico. Nos faltaría ahí una central hidroeléctrica más, que es un proyecto que nunca se realizó en Argentina porque económicamente se evaluó inviable en el momento en que el hidrógeno verde no era una hipótesis. El proyecto Pantanito-Michihuahua lo que haría es un proyecto de 850 megas hidroeléctricos que tendría que tener un esquema como el que promocionaba Malcolm, un proyecto de turbina bomba para tener ahí una mega batería de acumulación hidroeléctrica para poder sostener todo el proyecto. Y la verdad que eso sería para nosotros significativo en términos eléctricos, en términos de estabilización de la potencia al proyecto de Fortescue, de electrólisis, en el otro extremo de la Patagonia. Y la verdad que en un punto eso es lo que estamos pensando nosotros desde IMSA en términos hidroeléctricos. Tenemos las capacidades tecnológicas para la producción de turbinas bomba y en un punto estamos, por supuesto, analizando y evaluando el proyecto internamente dentro de IMSA. Cuando tengamos maduro el proyecto ejecutivo, por supuesto lo charlaremos con Fortescue, pero este es el tipo de cosas que estamos pensando hoy en Argentina, en IMSA, para ayudar, para asistir, para darle mayor garantía de energía firme a un proyecto tan significativo como es el de Fortescue.
Super. Thank you very much, Marcelo. It's very exciting to see what you're doing in Argentina, and the reinforces what Malcolm was saying about the mix that is required, and that's a good segue to Jerome Perez. Jerome, you're the senior vice president at GE, in charge of energy transition. I would say probably the most important job in the organisation. So you are a major equipment supplier in renewables, and I'm sure that green hydrogen is pretty central to your planning going ahead. Can you say a little bit about how green hydrogen fits in, and particularly how you're planning for some of that energy mix as we've seen with Marcelo in Argentina?
I think thanks, Andy. I think it fits essentially in three places. First, it's going to drive a massive amount of extra demand for our wind turbines, our hydro turbines, and everything we produce. So I think the first thing we are working on is how are we going to cope with this extra demand, not only in terms of adapting our supply chain, but also probably in terms of designing wind turbines, hydro turbines, and maybe controls that are more suitable to feeding an electrolyzer versus feeding the electricity grid. For example, if you look at some of these very large green H2 projects that you have in South America, like the one you discussed, and there are others in Chile, it might not need the wind turbine that we are producing today for traditional needs. It might need a wind turbine with less electronics into it because some of these projects are going to be off-grid, but it might need wind turbines with much higher capacity factors so that you maximize the load into the electrolyzer. So again, first pillar is how are we going to accommodate this extra demand with suitable technologies and at the scale that the green H2 development would require. Second thing is how are we going to combine renewable together to provide highest capacity factors and highest loads into the electrolyzers. I mean, we have been working since 2-3 years, or any combination of wind, solar, storage, and hydro to maximize capacity factors for electricity production. When you move to green hydrogen at scale, that's going to be even more demanding. I believe that a significant part of the demand for green hydrogen will not be met by wind only, or solar only, or hydro only. It will be met by some combination of that. And how do you combine and orchestrate these different sources of renewable with the right control system to feed the electrolyzer in an optimal way is the second thing that we are working on. And here, as Malcolm said, pump storage can probably be play a key role. I mean, pump storage, before green hydrogen, pump storage is critical, hydro pump storage, to balance the intermittency in renewable. When you want to feed an electrolyzer, if you want to maximize the load factor, you will have the same need. And we do believe of the combination of pump storage with other renewable to be a core pillar of green hydrogen production. And the third thing that we are working on is beyond this assembly of different renewables, how do you manage the power systems that will be the electrolyzer? That requires some skills in terms of understanding the grid, of developing and managing microgrids, because any of these systems will be a microgrid, particularly when the project will be off-grid. So we are developing projects in our power conversion business, in our grid automation business, to make sure that we provide the right equipment and the right control to manage what will be complex microgrid and complex power systems. So again, it's about these three pillars: product development, technology development, and being able to scale up to some of these large projects. Because just to give an example to finish talking about wind, I mean, some of the projects that people are talking about for green hydrogen production, I mean, in South America, but also in Africa or in Australia, are kind of 8-10 gigawatts of wind turbines. That's the size of the US market in a decent year. So we'll have to scale up. So again, that's a significant opportunity and a significant challenge for our one business, and also too close for our hydropower business, because we are convinced that pump storage can play a role as a component of green hydrogen system, and as Malcolm said, baseload conventional hydropower in some geography like Scandinavia can also be the pillar for green hydrogen production. So that's what it means for us at General Electric.
Thank you very much. I mean, this may sound like it's frontier technology, but I remind everybody of what Marco Alvera said yesterday. It is complex, but compared to the types of things they're doing for deep sea oil and gas, this is play school stuff, isn't it? I think we got to keep this in proportion. Good luck. It's really important. It's probably the frontier politics and the economics which is more challenging. Let me turn to Sharon. Sharon Becker is the co-founder of Impact Hydrogen. You're the director of Hydrogen Valleys. which is trying to link green hydrogen with the SDGs. Can you tell us, Sharon, a little bit more about how that's going to work? How does it contribute to the SDGs and why?
Well, it's not on.
It will come.
Testing. Hello? Yes. So there's a great opportunity ahead of us now because we are designing a whole new economy and designing hydrogen valleys. So the concept of organizing a part of the hydrogen value chain in one location or in one region means that you can also design it and operate it in a way that it not only contributes to the global climate goals, but also to the regional SDGs. So, for example, obviously the local energy transition goals, but for example, it can contribute to a local economic development, for example, by involving local SMEs, but investing in education, skills building, knowledge development, also bridging the gender gap. And so by investing in all these SDGs, you make sure that the benefit is on both ends of the pipeline, so to speak. And that is not just a nice to have, of course it is nice, but it's also a necessity, because for long-term stable trade relationships, it's necessary that in the regions where these hydrogen valleys are developed, that these are stable, that there's public support, especially with hydropower. I think we all know that there's been a lot of problems in the context of SDGs with hydropower development, especially the mega dams, with an enormous impact on ecosystems, resettlement of people. And so we can learn from the past, not only by not doing harm anymore, but also to take it broader and to ensure that the whole the hydrogen transition is not just green, but it's also just.
Thank you. There's a good reason why this session is called Sustainable Hydropower. I mean, we as the oldest and by perception, not in reality necessarily, the ugliest of the renewables. Well saved. It's yeah, mic drop. That's the moment. So we have of course learnt lots of lessons in the sector, and we brought that together in hydropower sustainability standard, which we'll come on to in a bit. But let's try and just do one more quick round, pick up the pace. I really want to focus on scaling up projects and the role of hydropower. And I'm going to ask us all to keep to 1 minute maximum each, so we have a little bit of time to ask the audience some questions. Malcolm, you talked about the scheme in New South Wales. The problem, as I understand it, with so much of hydropower is that the markets are very good at rewarding electricity generation, not so good at rewarding reliability, flexibility, and storage. So it's a bit like if you had a football team and you paid all your players except the goalkeeper, because the goalkeeper doesn't score your goals, but it's going to save you, right? What can we do? How can we bring this together? You've got the New South Wales one. We've got to do a lot more to help, particularly politicians, to understand this.
Yeah, thanks, Eddie. Well, look, very quickly, every electricity market or energy market, jurisdiction if you like, has to work out, you've got to work out what you want. And if you're talking about the electricity market, you've got to work out, as your coal generation goes out, you've got to work out how much storage and at what durations you're going to need. And having done that, you then need a mechanism to procure it on a competitive basis. Now you can do, you can do what happens in China where the government just builds it. I mean, that's what I did with Snowy Hydro 2.0, but Snowy Hydro, as those who are familiar with the history in Australia, is a very sort of, special, unique engineering marvel. It's always belonged to governments. In fact, I nationalised it, so it belongs to the national government now. But either the government did it or nobody. So it's sui generis. Going forward, you need to have a competitive program where you've got a degree of support and underwriting, and you say, whoever can give me, if I want 400 megawatts for 12 hours, whoever can give me 400 megawatts for 12 hours at the lowest subvention gets the gold. And I think that's pretty straightforward, but you've got to work out what you need. And in terms of ancillary services, you're absolutely right. All of that used to be provided free because you just had big thermal generators, big spinning, big lumps of steel spinning around. They provided all of the inertia that the system needed. Now, with so many inverter-based technologies, well, particularly in Australia, solar, we need what we called, FCAS services and frequency maintenance and all of the other ancillary services. So again, you've got to pay for them. Now that is now happening in Australia. Those of you that follow this stuff will have noted that the first big battery in the world, I think, was built in South Australia. So like a 135 megawatt hour battery, the Horndale battery, and everyone assumed it'd make its money out of arbitrage. It made almost all its money out of FCAS, out of frequency maintenance, because as the system drifts, this frequency drifts, above or below where it's meant to be. Battery can deal with that, but what you cannot beat hydro for is inertia. There's no substitute for a big turbine spinning, whether it's being spun by water or in reverse, if you like, providing that inertia. So work out what you want and have a competitive process to pay for it. That's simple.
Yes, very simple on paper. We've got to get that message out there. Yeah. And Jerome, I presume you would agree with much of that. What we heard yesterday was, and Antoine repeated this or echoed this, is that the costs of production for hydrogen are going down. It's becoming competitive in that sense, but the challenge then, the focus moves on to the costs of storage, the costs of transport, the costs of the infrastructure.
Yeah, it's the cost of I think two things on my side. One, it's the cost of the whole system that will matter at the end. I think the cost of renewable electricity is already competitive, and the cost of green H2 will fall very, very fast. So if you want to make a step change to the cost of the whole system, then it comes down to some discussion around carbon tax somewhere in the world, in many places of the world, which will be probably the fastest way to move the needle. Second thing, if you think about regulation and what government can do, as I said before, this will require a massive extra amount of renewable in the world. The world is already not moving fast enough in terms of renewable growth, even pre the upcoming growth of green hydrogen. And one of the big bottlenecks is permitting. It's true for wind, it's true for hydro. So which means that one place where governments can also make a difference is accelerating the permitting process for wind, for solar, for hydro, because otherwise it's going to be a bottleneck for the growth of renewable today and for the growth of green hydrogen tomorrow. You need to move these permitting matters much faster so that you can keep up with the pace.
Brilliant. Okay, more focus on permitting. Can I also now turn to Sharon? look, I spoke just now about the hydropower sustainability standard, which is a multi-stakeholder standard. It's independently assessed, launched last September, largely or partly based on that. The green hydrogen standard out yesterday. Delighted. That's wonderful. Are you happy with it?
Well, I'm definitely very delighted to see that the standards also include socioeconomic standards and ecological standards. Of course, now the key question is how do you apply them? Because the standards are universal, and that is great. But of course, the differences between the regions where the hydrogen production is planned, they differ greatly. So every value chain design is also very different. Is there a co-location between hydropower and other renewables? It makes it more complex, also means that it makes it more complex how to apply standards. So what is needed is a mapping of the needs in terms of the regional energy transition, a mapping of the SDG gaps. So they will be very different for each region. And of course, also the opportunities, because on the intersection of a new energy economy and where the greatest needs are to accelerate the SDGs, there is where the magic happens. That's where you can leverage programs. And I think the key is also that we should not just look at ticking the SDG boxes in the design stage or somewhere along the road, but it should be about a more holistic approach. So structural financing of impact programs, also in co-creation with local stakeholders who are actually representing those SDGs, so they can also secure that the right goals are set and the progress is monitored, the impact is monitored in the right way. So, as I said before, this is not a nice to have, this is essential to ensure a long-term healthy hydrogen valley, and this new economy will only work if everybody benefits.
I think that's really important message on large infrastructure. Again, from my organisation, we say the only acceptable hydropower is sustainable hydropower as measured and by the standard, but it does include, we need to look a lot at those impact issues. Antoine, of course, we can't talk here without the context of high energy prices right now. And can you say a bit about how these kind of hybrid projects around the renewables might help drive some costs down? Is there anywhere we can really be looking at as a potential hotspot?
Yeah, there are a number of hotspots. So the EU came out in March with its REPowerEU plan, which I'm sure everyone is aware of. Well, it's a plan to wean Europe off Russian gas. There are a number of targets that are set. A provisional sort of 2027 target for ending gas imports, and then by this year there's a reduction of just over 100 billion cubic meters of gas. And hydrogen plays a role there, as does renewable power sort of writ large. And that's an opportunity to seize, and just in a context where renewables deployment is going to have to increase, there are a few things to bear in mind. So there's a 20 megaton consumption target at an EU level that's been basically upped, and that's a significant scale up in ambition. That's going to be difficult to meet. That's about 4 times higher than what BNEF sort of had in terms of consumption by 2030 for a net zero scenario. So that's great. It's a good signal. It just is going to be tricky to ramp up production of sort of traditional renewables such as solar and wind in time. And it's worth considering as well that there's what we're seeing in terms of our lower scenario before this target was put in place for a system that would provide power in Europe for hydrogen as well as the electricity, sort of the wider power sector, got to about 5% of total land use. And already in countries like Germany, we're seeing permitting issues, acceptance issues, lack of sites for onshore wind, for example, at about 1%. So using that existing hydropower base, considering availability of sites, being more flexible with permitting starts to make a lot more sense, and doing so in a sped up way is really a priority. The EU's talked a big game on setting up one-stop shops for permitting or putting pressure on member states to develop sites. That's not been an area where we've seen a lot of progress, but it's a priority area. Another is a sort of recognition of the fact that there'll be a European reliance on imports of hydrogen, lots of the countries positioning themselves to export, whether it's Paraguay or Brazil or Canada, or Argentina, of course, have large installed volumes of hydropower available, so making sure that the rules are in place within some of those import schemes to accept hydropower produced hydrogen is probably worth writing in and adjusting. And for example, the German government's H2 Global scheme is very much focused on wind and solar produced hydrogen. There'll be future schemes at a European Commission level, for example, that could take a bit more of a wider look at what other renewable energies are available. So I think there's a number of specific issues and a number of areas that aren't being looked at close enough. And hydropower right now, when we look at hydrogen projects in Europe, is the cheapest option for using existing capacities, and we're seeing that in the Nordics. So it's something to be borne in mind and really pushed by policymakers.
Thank you. Some common themes coming up, which I'll come back to. Just a final question from me to the panel. Marcelo, you covered it a bit in your earlier presentation about what Argentina is doing to produce hydrogen in situ, where there are hydropower sites. What's your advice to others in trying to actually produce hydrogen next to hydropower plants?
Bueno, ¿cuál es el mensaje? Sin ánimo de ponernos místicos, hay una coincidencia temporal entre pandemia y la aparición del hidrógeno verde. Quizá algo nos está diciendo que es momento para cambiar, y quizá el hidrógeno verde es una oportunidad, una nueva opción para hacer las cosas de otra manera. Y eso es una señal, a su vez, para la industria hidroeléctrica en general, hacer proyectos sostenibles. Y en ese sentido creo que el estándar de GH2 nos marca el camino, recién lo comentaba Sharon, de que podemos hacer las cosas bien, que podemos hacer las cosas de una manera sostenible, de una manera sostenibilidad social, sostenibilidad ambiental y sostenibilidad económica. Si podemos pisar esos tres pilares en una mesa, apoyar esos tres pilares en una mesa, tenemos básicamente lo que necesitamos para seguir adelante. Hidroeléctrica tiene que acompañar inevitablemente, irreversiblemente, los proyectos de hidrógeno verde, tiene que hacerlo con proyectos sostenibles, con proyectos no solo económicamente eficientes, sino también ambiental y socialmente eficientes. Por eso, desde IMSA estamos muy gratamente aplaudimos la aparición del estándar GH2 y, por supuesto, estamos listos para adherirnos. Así que en ese punto, muy expectantes con lo que viene.
Very good, thank you. Just before you jump away, I just want to open it up. Just any quick questions. We've got one moment for a round. Yes, please, come on. Thanks, Birgitte. Please introduce yourself.
So my name is Birgitte Jordan Anderson. I work as a partner in Schjøtt, but before I was actually lobbying and coming from Norway. It's a no-brainer that I think hydro is important. And I was lobbying in Brussels very much on behalf of Energy Norway. And I was also working in DG Energy, so I have seen all of the sites. The problem is that hydropower, for me, it's a no-brainer, but for Europe, it is losing, it's losing power. And it's in a taxonomy, for instance, we were fighting hard to not having that transitional activity, which we manage. But now we see it again coming around in the reports coming up for the next technical criteria. And today, DG Energy, the Commission, came up with the additionality. I was reading the leaked document, the third leaked document that we were really fighting hard for down there in Brussels. And it's, again, it's going to be problematic with regard to hydropower, especially when you want to shift to wind and hydro at the same time, because then you fall within this very difficult technical criteria again. So what do we do? Because globally, I would like to hear how do you fight that if you have this vision? Because a lot of NGOs in Brussels are of the opinion that hydropower is not actually a renewable source. Do you see that in your respective countries? And what kind of advice do you have for us here in Europe so we can keep the, really fight for hydropower, which I think is a no-brainer?
I think there are a number of things we can do. I mean, first is making sure that we can't keep promoting the sustainability of hydro and the benefits hydro is bringing to the whole electricity system. Because when you add pump storage in Europe, you at the end make up something which is better overall for the environment by stabilizing the electricity grid. And pump storage works in closed circuit, which means you are not taking water out of the system. So I think there is still a lot that needs to be done in marketing the benefits of hydro. The second thing that we need to do together as an industry in the hydropower business is accelerating the time between the start and the end of the project. Today, between permitting, engineering, civil construction, electromechanical construction, you are talking about projects which take 5 to 7 years to complete, if not more. And we need to make that shorter so that hydro is not only considered as more sustainable, but considered as something that you can make happen tomorrow, not the day after tomorrow. I think that's the two things that comes to mind.
Sorry, thank you. Well, look, thank you, Birgit. I think this is a very, very retrograde idea, if that's what the EU is doing. I've got great reservations about the whole additionality concept anyway. I mean, the market should be able to work that out. It's hardly likely that the green hydrogen industry is going to push up electricity prices, if you think about it, because clearly, even green hydrogen is looking for very low electricity prices. I mean, typically people promoting green hydrogen projects, are looking for energy at, sub $40 a megawatt hour. I mean, I won't go into too many details, but it's not, they're absolutely not wanting to pay top dollar. So I think this is a solution to a problem that doesn't exist. But I mean, that's obviously what bureaucracies do all the time. But certainly excluding hydro is, I think, is quite perverse. And I can't see any prospect of that happening in Australia at all. I think hopefully we're too sensible for that.
If I may just say... Thank you. Thanks, Malcolm. I mean, it is frustrating. It's really frustrating. It is the legacy of a long period where the industry didn't do well enough, and I think the industry has to hold its hands up, and I believe it is. As I said, my organisation, its members, a third of the installed capacity of hydropower around the world, has said the only acceptable hydropower going forward is sustainable hydropower. And there is a standard for it, and it is aligned with the green hydrogen standard. We have to make sure that's rolled out. We have to work hard on the perception of the sector, make people understand that it is by using hydropower Today, you are displacing 4 billion tons of CO2 emissions if it was equivalent in coal. And that is a really, really important message. I have to say, climate NGOs on the whole really get this. There's a big movement. There's a lot of work still to do with conservation NGOs, and they have legitimate concerns, really legitimate, which we need to do better as a sector. So the two working together, that's what we've spent our last 3 years working really closely with the NGOs and trying to work on this perception and then get also, well, at the same time, the policymakers to understand this. With that, it's very greedily, I've stolen the last word, which is very unprofessional, but I do see time is upon us and I'll get into big trouble. Can I thank the panelists very much and thank you all for joining in.
Thanks, Eddie. Thank you.